Assalamualaikum and very good day to everyone. Hi, I'm Awanis Romli, a lecturer from University Malaysia Pahang. Today's lab session is focusing on the introduction to normalization and the types of anomalies. At the end of these lab sessions, students will able to identify the problems or issue occurred when we not normalize the database. And upon the completion of this lab session, students will have the ability to analyze and identify three types of data anomalies that occurred in the database, which are insertion anomaly, deletion anomaly, and update anomaly. First thing first, what is normalization? Normalization is a technique of organizing the data into multiple related tables. And why it is important? Because it can minimize the data redundancy. Data redundancy is a repetition of similar data in one single database. And this repetition of data will increase the size of database. Other issues occurred when we don't have normalization in our database, which are insertion anomaly, deletion anomaly, and update anomaly. Okay, let's go to the question number 1. Explain three types of anomalies presented in table 1. And student needs to illustrate with examples. We can see here in table 1, there are 4 attributes which are customer number, name, salesperson, and state. First, I will explain insertion anomaly scenario. If we have a new salesperson that we want to assign to Kedah, example, salesperson name is Izan. Here, we cannot add or enter the record of Izan until we know the value of customer number and name first. One row needs to be completed. Second scenario is about deletion anomaly. If customer number 6837, we want to delete this customer number. Automatically, the data about Hamzah as a salesperson that assigned to Kelantan also will be deleted, even though we actually want to keep this information for Hamzah. And lastly, the third about update anomaly. If we want to update the record for the salesperson T has been reshuffled to the new state from Selangor to Terengganu. Can you imagine if you have 3,000 records in the database and the record for T is 500? What you need to do? Yes, you need to find the record for T. You need to check line by line the record for T and update the information for the state from Selangor to Terengganu for 500 records. Can you imagine? Now we go to the question number 2. For the question number 2 is just similar with question number 1. You need to identify and explain three types of anomalies by using example from table 2. So for the first one, insertion anomaly. A new movie cannot be entered until it has been assigned to a distributor. A value for distributor ID must be provided to insert a new row in the table. Secondly, about deletion anomaly. If distributor ID number D1234 is deleted from the table, we will lose the information on movie M4567, which is Hantu Kak Lima, movie Police Evo 2, and also movie Sepet, because we delete the distributor ID number D134. For the update anomaly, if movie for Sepet is update the price category from 3 to 2, several rows must be changed to reflect that fact. Again,
we need to find line by line the record for SEPA, which is we want to change price category from 3 to 2. So first, we already changed for the SEPA number 1, and then we find it again, we change it 3 to 2, and lastly, we find it again in the SEPA from 3 to 2. It will take time, and because of the data is same, it is a repetition of that data, and we need to do something about this.
We have done 2 questions for the lab session. Now let's recap. Why we do need normalization? Yes. First, we want to remove redundancy in the database. And when we remove redundancy in the database, it's easier for the user to access and maintain the data. And also, we can take up minimal storage space on the computer. And what will happen if we don't normalize the database? Then the 3 anomalies will occur, which are insertion anomaly, deletion anomaly, and update anomaly. In the next lab session, we will discuss how normalization can solve these anomalies. And also, we will learn how to analyze and identify functional dependency and decompose from first normal form to third normal form relations. Till we meet again, and thank you for being with me today in the lab session. It's nice to have you all in this lab. Thank you and bye-bye.